Alright, so this question says there are 30 balls, each a different color, and 30 boxes in the same 30 colors. One ball is placed in each box. How many ways can the balls be placed so that exactly 3 of the balls do not match the color of the box they're in? Okay, so let's break this down a little bit. The first thing we want to note is that the question is asking, well, how many ways, right, can these balls be placed so that exactly 3 of the balls do not match the color of the box that they're in? So we have 3 colored balls that don't match, and we're trying to find the way to rearrange all of these. But first we have to figure out, well, how many ways can we pick these 3 colored balls? Because if there's 3 that don't match, well, then there's going to be 27 that do match. But these are simpler. Like, let's say we pick, for the balls that don't match, we pick red, yellow, and blue. Well, then all our remaining balls, like let's say pink and orange and green, they're all going to go into the pink and orange and green boxes. So there's only one way to rearrange the balls that do match. I mean, those are just going to be placed in their corresponding boxes. And then there's multiple ways to rearrange the balls that don't match their boxes. But first, our first step is going to be, well, how many ways can we pick 3 different colors for the ones that don't match, right? Because we don't have to pick red, yellow, and blue. We could pick pink instead of blue or green instead of yellow. We just need to find a way to figure out how many ways can we pick 3 balls out of those 30. Well, from the way the name kind of suggests, we're choosing 3 balls out of those 30. We're going to be using the choose function. So we're going to be doing 30 choose 2, which, or 30 choose 3, sorry, because we're picking 3 out of those 30, which is the same thing as 30 factorial over 27 factorial 3 factorial. So that's going to be equal to 30 times 29 times 28 times 27 times 26, blah, 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 all the way to times 1. And then the 3 factorial is going to be 3 times 2 times 1, because remember, a factorial is just an integer, well, a number times every integer less than it. And then the 27 factorial will be 27 times 26, blah, 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 all the way to 1. So if you notice the 27 factorial on the top and the bottom, it cancels out. And so we're left with 30 times 29 times 28 over 3 times 2 times 1. So we can divide the numerator and denominator by 6, and so we end up with 5 times 29 times 28. Okay, so what's 29 times 28? Let's do that real quick here. Carry the 7, 16, 23. 29 times 2 is 58. And we add these. Oops. And we should, wow, this technical difficulties, we should get 812. And we're multiplying 812 by 5 to get the number of ways that we can pick those three balls. So I don't want to actually go ahead and multiply all this out right away because that's a really big number, and maybe our next step will help us. So this right here is the number of ways to pick 3 right here. And so now we've got to figure out, once we pick those 3, how many ways are there to rearrange those 3? So like, let's say we picked red, yellow, and blue, and so we're gonna have this is gonna be our red box, this is gonna be our yellow box, and this is going to be our blue box, okay? And then we have to take the red, yellow, and blue balls and rearrange them in here so that they don't match the colors, right? Because that's what the question is asking. So let's say, well, we're going to start with that red ball, okay? So we're going to pick somewhere for that red ball to go, and then based off of that, determine how many ways are there for that blue and yellow ball. So the red ball can't go in the red box, but it can go in the yellow box. All right, so if the red ball goes there, well, let's look at the blue ball. The blue ball can't go in the blue box, so the blue ball has to go in the red box, and therefore the yellow ball has to go in the blue box. There is only one possible option. Once you decide that red ball goes in that yellow box, everything else is fixed. You can't choose where they go. There's only one possible scenario. So let's try to see what happens if you put that red ball in the blue box instead of the yellow box. Okay, so we put the red ball here. Well, now that yellow ball has to go in the red box, and therefore the blue ball has to go in the yellow box. So once you put, like, there are only two places to choose where to put that red, and then once you put that, everything else is fixed. And so you'll find that these two are the only possible ways to rearrange all these three balls so that they don't match the color of their boxes that they're in. And we started with the red ball, but you could start with a blue ball or the yellow ball. Since this is symmetric, we're trying to do the same thing to each ball. You'll get the same results and the same exact combinations. So there's three ways to pick the balls that don't match. And then for all of those ways to pick those balls, there's two ways to rearrange them. So our final answer is going to be, or I guess I should write this here, 2 ways to rearrange. That's what this little diagram is showing us. So our final answer is going to be 812 times 5 times 2, which is going to be 812 times 10, or 8,120.